In the second half of Lesson 8.2, we're going to simplify expressions containing negative exponents. Using numbers to find a pattern, let's see what happens here. We have 2 to the second, just 2 times 2 over 2 to the second. And we know very well that anything divided by itself is 1. And so I have 1 over 1, and 1 divided by 1 is 1. Now, if we used our power divided by power subtract exponent strategy, we would have had 2 to the 2 minus 2, which would be 2 to the 0. So it appears that 2 to the 0 is the same as 1. Let's try the same thing with 2 cubed. Again, anything divided by itself is 1. This time I'm going to have 3 1s in the numerator and 3 1s in the denominator, which 1 times 1 times 1 is still 1. And again, if we switched over and used our quotient rule, 2 to the 3 minus 3, power divided by power subtract exponents, we get 2 to the 0 there also. So it looks like whatever we do, if we have anything that's 0 power is going to be 1. Any non-zero number raised to the 0 power is 1. For any non-zero number a to 0 is always going to be 1. And if we stick anything inside those parentheses like negative 0.25 and raise to the 0 power, we get 1. These are kind of fun because whatever mess you have inside those parentheses, when they say simplify, it's really going to simplify. Because anything, and we mean absolutely anything, raised to the 0 power is 1. I don't care if it's 12m to the 8th n to the 7th over 8, which I could have simplified all this stuff in here. Yeah, divide by 4, but you don't need to because it's all 1 anyway. So there will be someone that goes to all of this work and then goes, why isn't my answer right? Oh, because it's raised to the 0 power. Anything to 0 power is automatically 1. You can just write down your answer, you're done. Now this isn't all raised to the 0 power, so it'll be a little bit more interesting. Since the m is to the 0 power, just that one term reduces down to 1. And of course, when we take 1 times anything, we get what we had. And using our quotient of powers rule, power divided by power, we subtract exponents. And 3 minus 2 is 1, but we don't normally write the 1, so our final answer will just be n. Now sometimes that quotient of powers rule will yield a negative result. If we look at 3 squared over, or divided by 3 to the 5th, if we do our quotient of powers rule, we'd have 3 to the 2 minus 5, which is going to be negative 3. Now, I just went ahead and did the rule, but let's look at what happens with writing it out. Again, anything divided by itself is 1. Goodbye, 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 goodbye. So I ended up with 1 over 3 cubed. So here's our correlation. Negative exponents is the same as reciprocal. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. In addition, the reciprocal of a to the negative n is a to the positive n. For any non-zero number a and any integer n, a to the negative n is the same as 1 over a to the n, and 1 over a to the negative n is the same as a to the n. Okay, so 5 to the negative 2 is the same as 1 over 5 squared, which is 25. Or 1 over m to the negative 3 is m cubed. Negative exponent is reciprocal. When you see a problem like this, you say thank you very much, because all we need to do is switch places and we're done. Negative exponent means reciprocal. Now they're showing what they're doing, which is very nice. I wouldn't take the time to write this all out. So they're going to do the reciprocals. So what was a negative exponent is now a positive one because we're doing the reciprocal. Oh, we didn't have to do the reciprocal as e. It can just say z to the 9th. And since 1 times anything is itself, ta-da. Now, for me, I would simply look at those and go, hey, you have a negative exponent. You need to go to the other side. And then we're done. And the z stays where it is. Oh, simplify. Nice directions. Yes, we should assume that the variables are not equal 0 because division by 0 is a bad thing. I do kind of like how they separated this out because a lot of people get freaked out over, of all things, the number part. The number part's the easy part. What can we reduce these by? Well, it looks like they're both divisible by 5. Oh, I guess I could have done 15 in the first place because now I can divide by 3. But that's okay. You can do that with reducing. It's all right. And then, of course, power divided by power, we subtract exponents. And even a minus negative. Ooh, minus negative. We know what to do there. That becomes a plus. I kind of wrote over my 5. So that should be 5 plus 4. Oh, yeah. Negative exponent. They just said, hey, negative exponent means reciprocal. That's cool. Okay, now it looks like we're done. 3 minus 5 is negative 2. 5 plus 4 is 9. But one more thing. They'd like us to leave our exponents positive. We're positive people. So we know negative exponent means reciprocal. And if we just clean that up, we end up with 5 q to the 9th r to the 8th over p squared. Nice final answer. Okay, they do love these on ACTs. I know, you guys got a ways to go to ACTs, but it's good to start practicing this type of thinking because it's really different. Write the ratio of the circumference of the circle to the area of the circle in simplest form. Ooh, so we need to know the formulas for circumference and area of a circle. I was saying circle, the word is square, rats. Okay, so the circumference of a circle is 2 pi r. It happens to be the length of one side of the square would be the diameter of the circle, which would be 2 radii, so 2r. So the area of a square is going to be 2r times 2r. So the ratio of the circumference of the circle to area of the square, we have 2 pi r over 2r quantity squared. So 2 squared is 4, and then we have our r squared. And power divided by power, we subtract exponents. I'm pretty sure we can handle that 2/4 business. Be 1/2. And 1 minus 2 is, of course, negative 1. Oh no, negative exponent, what are we going to do? Oh yeah, that's right. Negative exponent means reciprocal. So we just need to take that unhappy r and bring it to the other side of the fraction bar. That's supposed to be an arrow. So we end up with pi over 2r as our final answer. Oh yeah, I guess there are multiple choices up here. So, go with C. Always a good choice. And now we have everything you'd ever want to know about dividing monomials in one convenient location. To divide two powers that have the same base, subtract the exponents. To find the power of a quotient, find the power of the numerator and the power of the denominator. Any non-zero number raised to the 0 power is always and forever 1. For any non-zero number a and any integer n, a to the negative n is the same as 1 over a to the n, or 1 over a to the negative n is a to the positive n. Be positive, people.